Hi everyone. In this lesson we're going to look at how to generate sample proportions with our calculators. So a sample proportion is a specific concept that we need to be aware of. So when we do a sample proportion, it is x over n, and this is the number of successful outcomes, and this is the number of trials. So these are a binomial situation. Now what have we got to look at here? We want sample proportions from a sample of 40 trials. That would mean n equals 40. And the probability of a particular property is 0.65. So that means the chances of success on every individual trial is 0.65. Now, how do we do this with our calculators? Let's take a look. So we go to the Run Matrix menu. I'll just delete what I had there. We go Options, Probability, Random. Now this is a binomial situation, so it's a binomial probability. If I was to give this, if I was to say there's 40 attempts or 40 trials in this experiment, the chance of success in each one is 0.65, then that's not quite what we're talking about. That's giving me 25 successes on that attempt. But I need a sample proportion, don't I? I need two of these sample proportions. I don't just want one of them. So I'll come back here, I'll put a comma, and I'll put 2. Now, I get a list this time with 2 outcomes. On the first experiment, I had 28 successes out of 40. On the next one, I had 29 successes out of 40. But how do I actually make these into a sample proportion? These are the values of x. These numbers 28 and 29 represent how many successes there were. I'm supposed to generate sample proportions. Well, we generate a sample proportion by dividing by n. So if we divide by 40, then each of these is now a sample proportion. So 40 trials with a chance of 0.65. The first outcome, when I divided by 40, gave a sample proportion, p hat, of 0.675. The second one gave a sample proportion of 0.75. So I've generated 2 sample proportions from, yes, there were 40 samples, and the population had a particular property which was 0.65. Both of those sample proportions are reasonably close to 0.65. And we compare them. Okay, well, both of them were a little bit on the high side, but there's only 2 of them, so that's not terribly surprising. Be careful if the question states that they want a sample proportion. It means you need to divide here by the number of trials, in this case divide by 40. Thanks for watching.